Hello everyone, this is Moshimi. We have been discussing kinematics and we have covered certain topics as uniform and non-uniform motion, and today we shall be discussing projectiles and their motion. Now what is a projectile? Is it some hardcore device? Not really so. Projectile is in fact any object that has been thrown with some initial velocity near the surface of the earth and which falls under the influence of gravity alone. Now, some common examples of projectiles may be the motion of a bullet fired from a gun, the motion of a bomb released from an aeroplane, or you must have seen water fountains in amusement parks. They too demonstrate projectile motion. Now, whenever we are talking about projectile motion, we make two assumptions. First, the absence of friction. Friction is the force that opposes motion. So we assume while discussing or describing projectile motion, we assume that friction is not present. And the second assumption that we make is that acceleration due to gravity g is uniform everywhere. Though we know that acceleration due to gravity varies at the equator and at the poles. But even then, we make certain assumptions in explaining projectile motion. Now, there are a number of ways in which a projectile may be launched. Let's first discuss the case of horizontal projectiles. Now, what is a horizontal projectile? You can imagine the motion of a stone when it is taken to the top of a tower and thrown from the top. Now, whenever an object, a projectile, it is thrown horizontally with some initial velocity, say u, from the top of a tower, we will see that it follows a certain path and then hits the ground. Now, using one of the equations of motion, we can write down expressions for the horizontal and the vertical distances that the projectile covers during its motion. Now, whenever a projectile is thrown horizontally with some velocity, it traverses a certain horizontal distance and also traverses a certain vertical distance due to the influence of gravity. Now, what are these distances? Let us try to write down expressions for that. We shall use the Newton's law of motion and we shall try to apply the equations of a uniformly accelerated body. We will use this particular equation, S equal ut plus half at square. Now, the horizontal distance that the projectile covers is due to the influence of the horizontal component of this velocity. The initial velocity u, the horizontal component of that velocity is ux, and this particular velocity has no vertical component. So, the horizontal distance traversed by the horizontal projectile is given by s, which is equal to ux, the horizontal component of the initial velocity, times the time, plus half the x component of acceleration and the time. Now, in this case, we will see that we have kept ux as equal to u. So, we will keep this as ut. And mind it, as the projectile has been projected horizontally, there is no component of acceleration in the horizontal direction. So, this gives us ax as equal to 0. So, we are left only with an expression x equal ut. This is the horizontal distance covered by the horizontal projectile. Now, what for the vertical motion of the projectile? This projectile will also follow a certain vertical motion because of which it will fall down and hit the ground. Now, that is on account of gravity alone, and the initial velocity has no role to play in it. So, suppose the vertical distance that the projectile covers is given by y. We shall use the same equation to write an expression for y, which is uy times t plus half of ay into t square. Now, as I told you, there is no component of initial velocity in the y direction or in the vertical direction. So, this uy is actually 0, and ay is the acceleration in the y direction, you can easily predict from the drawing that along the vertical direction, the acceleration that is playing a part is nothing but gravity. And since it is downward motion, so ay will be equal to plus g. We are left with y equal half gt squared. Now these two equations, I name them 1 and 2, these are called the parametric equations. 1 and 2 are the parametric equations. Now, it was Galileo who predicted that the path followed by a trajectory, the path followed by a projectile, which is called its trajectory, is parabolic. Now, with due respect to Galileo, let us try and find out whether a projectile really follows a parabolic path or not. How do we do that? Now, we know the equation of a parabola is y equal ax square, where a is a constant. Now, if we try to plot this graphically, how does the graph look like? This is the x direction, this is y. Now, we can see from this equation, if a equals 0, then x equals 0 will mean that y equals 0. So, we know that the graph has to pass through origin in this case. Now, for different positive values of a, if we plot the graph, we will get a graph of this sort. Now, if you choose negative values of a, you can see that the graph takes a form of this. So, we get a graph of this one. This is actually the path followed by a projectile, and this was said long back by Galileo. Now, let us try and find out whether the parabola that we are thinking of, whether that is the actual path followed by a projectile or not. For that, as we see, the equation of a parabola is an equation of y in x. So, we shall try to find an equation of y in terms of x. For this, from the first equation, we substitute the value of t as x by u, and we substitute this value in 2 using the second equation. So, let us try and find an equation for y. We have from the first equation x equal ut, or t will be equal to x by u, and we put this value of t in the second equation. So, we are left with y equal half g x square upon u square, or we can see this is g by 2u square into x square. So, doesn't this equation represent a parabola? You can compare the two equations. In place of a, we are having g by 2u squared. So, yes, Galileo was correct. The path followed by a horizontal projectile is parabolic. Now, there are other parameters which can be calculated using the equations of motion. Let us first try and find out the time taken by the projectile. You can see from the drawing that the projectile will need some time to complete its trajectory and hit the ground. So, what is the time taken by the projectile? We call this time as the time of flight. And if we apply this in this particular equation, which motion do we have to consider? Yes, it is the vertical motion that is to be considered. Now, s, or we can say the height of the tower, is given by h. So, from this particular equation, we can write h is equal to uy times t. Uy, there is no component of velocity in the y direction. So, the first term equals 0, and we are left only with the second term. It is half g t square, or we can write t as equal to, we take this as capital T, the time of flight, it is nothing but root over twice h by g. Now, take a note of this formula. It tells us that the time taken by a horizontal projectile to cover its trajectory and hit the ground depends only on the height of the tower. It has nothing to do with the mass of the object. So, this is the time of flight that we have. Now, you must have noticed that before striking the ground, the projectile has already travelled a certain horizontal distance. This horizontal distance is x, or it is better called the range of the projectile. So, range is basically the horizontal distance covered by a horizontal projectile in hitting the ground from the foot of the tower. So, we can write an expression for the range as r equal horizontal distance, which is ux times t, as we know that distance is equal to speed into time. So, the speed is the x component of the speed, that is ux, which is nothing but u into t, the time of flight. So, we can write an expression for the range as u times t, that is u into twice h by g. Now, if you are asked to find out that at any point on its trajectory, what is the velocity of a particle or the projectile? Suppose we choose a point P here. Now, at this point P, this is say the direction of the particle. We have the horizontal component, this is the resultant, that is Vt say, the horizontal component is Vx and the vertical component is given by Vy, and this angle that the resultant makes with the horizontal is given by beta say. Now, if you are asked to find out Vt, what will it be? You can see that Vx and Vy are the two rectangular components of the velocity. So, very easily we can apply the formula of Vt, that is Vt is nothing but equal to square root over Vx square plus Vy square. Now, what is Vx and Vy? Vx is the final velocity in the x direction, that is the x component of the final velocity. So, this Vx, we can obtain the values of Vx and Vy from the equation V equal u plus at. So, if we apply this equation, we can see that Vx will be equal to ux plus axt, ax is 0. So, we have Vx is equal to ux, which is equal to u as mentioned in the question, and Vy will be equal to uy plus ayt, uy is 0 and ay is g. So, Vy becomes equal to gt. So, if we substitute these values over here, we can see that Vt is equal to u square plus g square t square. So, this gives us the resultant velocity of the projectile at any point P on its trajectory. Now, we need to find out the direction of motion of the projectile. To find the direction, we have to find an expression for beta. So, we can see from the diagram that we can write beta as tan beta, which is equal to Vy upon Vx. Now, Vy is gt and Vx is u. So, this gives us an expression for beta as tan inverse of gt upon u. So, this is how a horizontal projectile behaves. Now, let us see the case of a vertical projectile. Before going to that, let us discuss some problems on horizontal projectiles. So, the first problem. A ball is projected horizontally with an initial velocity of 19.6 meter per second from the top of a tower. So, the initial velocity has been given. Initial velocity is u equal 19.6 meter per second. We are to calculate the time that elapses or passes before the horizontal and the vertical velocities become equal. As we know, the velocity has got both horizontal and vertical components. So, they are giving us in the question that the horizontal and the vertical velocities are equal, and during that period, what is the time that elapses? We need to find that out. So, first write down expressions for the vertical velocities and the horizontal velocities. We shall use the expression V equal u plus at. For horizontal motion, V becomes equal to Vx, which is nothing but Ux plus Ax times t. This is U and Ax is equal to 0 as there is no component of acceleration in the horizontal direction. Now for vertical motion, V becomes equal to Vy. Vy is equal to Uy plus Ay times t. Now there is no component of velocity in the vertical direction initially, so this Uy is 0 and we are left only with gt. Since Ay for downward direction, Ay is equal to g. So now they have given us in the question that Vx and Vy are equal, or we can write that gt is equal to u. So t becomes equal to u by g. U is 19.6 and g is 9.8 unless mentioned, and this comes out to be 2 seconds. So a time of 2 seconds elapses before when the initial and the vertical and the horizontal velocities become equal. Now the second problem. A projectile is fired horizontally with an initial velocity of 196 meters per second from the top of a cliff 980 meters high. Calculate the time taken by it to hit the ground, the velocity with which it strikes the ground, and the distance of the target from the foot of the cliff. So this is another problem on an horizontal projectile. The initial velocity has been given. We are to find out the time of flight, the velocity with which it strikes the ground, which means that we are to find out the resultant velocity at any time t, and the distance of the target from the foot of the cliff. This means that we are to find out the range of the projectile. So let us try and solve this problem. First we shall write down whatever is provided. We have initial velocity u, which is equal to 196 meter per second, and the height of the tower 980 meters. So we have the formula for time of flight, which is root over twice h by g. We put down the values, 2 times 980 by g, which is 9.8, understated. We are to take this value. So this is 100 and ultimately we get t equal square root over 200, which is 14.14 seconds. Now next we are to find out the resultant velocity, that is Vt. We remember the formula for it as square root over Vx square plus Vy square, which is nothing but u square plus g square t square. We put down the values. Vt is equal to square root over u is 196 whole square of it, and this is 9.8 into the time, that is 14.14 whole square of that. Ultimately this gives us Vt as equal to 240.04 meters. Finally, the range of the projectile, we have range r as equal to ux times t, or the time of flight, that is ut. We put the values, we have range equals u, that is 196 times 14.14, and this gives us a range of 2771.44 meters. Now let us discuss the case of a projectile that has been launched at a certain angle with the horizontal. Suppose we have a projectile that has been fired with a velocity, say u, and at an angle of theta with the horizontal. So this is u and this is theta. Now as you can see from the diagram, the projectile is fired with a certain initial velocity at a certain angle with the horizontal. Now we can write down, or we can break up this initial velocity into two rectangular components, u cos theta along the x direction and u sin theta along the y direction. So this particular direction, the component of the initial velocity is u cos theta, and in the vertical direction the component is u sin theta. Now under the effect of these two components of the initial velocity, the particle will cover a certain horizontal distance as well as a certain vertical distance. Suppose these distances are given as x and y. Now before going into the expressions for x and y, let me tell you a few more things about this projectile. Now take a note at the diagram. You can see that the horizontal motion is only because of this horizontal component of initial velocity. But the vertical motion of the projectile is influenced by two things. First, the vertical component of the initial velocity, and secondly, the influence of gravity, which also affects its motion. Now during upward motion, the particle is trying to move against the effect of gravity. So we are to take a note on the acceleration while writing expressions for them. Now look at the beauty of physics here. If an observer is trying to observe the whole scenario somewhere from here, he can see the horizontal motion of the projectile, and an observer looking somewhere from here, he can see the vertical motion of the projectile. Such is the beauty of physics. Okay, let me proceed further. You can see we have written down expressions for the final velocity in both x and y directions. Vx, which is equal to ux plus axt. Putting down the values of ux and ax, we get Vx is equal to u cos theta. Sorry. In case of horizontal projectiles, there was no component of initial velocity. But in case of a projectile that has been fired at a certain angle with the horizontal, there is a component of initial velocity, which is u cos theta. So we have this component in the expression for Vx. But there is no component of acceleration in the horizontal direction. So Ax is 0. This is equal to 0. Now in case of Vy, we have the y component as u sin theta, and Ay is minus g here because the particle is moving upwards. So the value of acceleration due to gravity will be equal to minus g. So we have written down expressions for Vx and Vy. Let us try and find out whether Galileo's predictions hold good in this case as well. That is, we shall now try and find out the path followed by the projectile. Have a look at this drawing. So this was the velocity of the particle, u, the initial velocity. The components were u cos theta along Ox and u sin theta along Oy, not forgetting that this angle is theta. So at any point on the trajectory, suppose we are concerned with this particular point here, say P. What is actually happening to these components? Let us think on this. As the particle is moving upwards, it is always being pulled by gravity so that it tends to fall down. This means that gravity is providing a opposition to the motion of the particle. As a result, the velocity of the particle as it is moving upwards will go on decreasing. And ultimately, by the time the particle has reached the maximum point, its velocity reduces to 0. And then beyond that point, the velocity again goes on increasing. So we shall discuss that in bit more detail after some time. Let us first concentrate on the path followed by the projectile. For that, we have to find an expression of y in x, where y is the vertical distance traversed by the projectile and x is the horizontal distance traversed by the projectile. So let's start with the equation s equal ut plus half at square. For horizontal motion, the horizontal distance covered is x, which is the horizontal component of the initial velocity, that is ux t plus half ax t square. So we can write x as equal to ux is equal to u cos theta times the time. Now have a look at this. Ax is 0 because there is no component of acceleration in the horizontal direction. Now from this, at one go we shall find out an expression for t. T will be equal to x by u cos theta. Now beyond this, let me write down expressions for y. Y is equal to uy times t plus half ay times t square. So we can write y as equal to this uy is u sin theta times t, and this is half, this is g, and this is t square. Now what will be the sign here? As the particle is moving upward against gravity, so ay is not plus g, it is in fact minus g, because the particle is trying to move against the effect of gravity. So we can plot the value of t from this particular equation into it. So we get u equal y equals u sin theta times t, that is x by u cos theta, minus half g t square, that is x square by u square cos square theta. Ultimately we get an expression for y as x tan theta minus gx square by 2u square cos square theta. So yes, Galileo was true. Here too we see that the path followed by a projectile is an equation of a parabola of second order, which means that the path followed by a projectile, even if it is projected at some angle with the horizontal, is parabolic. Now let us try and find out other expressions for the different parameters associated with projectile motion. So beginning with maximum height achieved by the projectile. Now have a look at the diagram. Whenever we are talking about maximum height attained by the projectile, it is nothing but the vertical motion that we are concerned with. So we shall consider this same formula S equal ut plus half at square and try to find out the time taken by the projectile in hitting the ground, and we shall use the expression v square equal u square plus 2as to find out the maximum height achieved by the projectile. So we have v square equal u square plus 2as. As I said, while talking about or while finding the maximum height attained by the projectile, we shall consider only vertical motion. So this v will take in the y direction vy, this is uy and this is ay, and this s will be replaced by h, which is the maximum height achieved by the projectile. Now what is vy? As I told you earlier, as the projectile tries to move upwards, it will reach a certain point and then fall back. So what happens is that the velocity of the particle goes on decreasing till it attains the point A, and beyond that it again increases. This is because gravity is affecting the motion of the particle. So we have Vy at the highest point, the velocity equals 0, and Uy is the y component of the initial velocity, which is u sin theta. Whole square of this, and this is in the upward direction, so ay has to be taken as minus. So minus 2g and s has to be replaced by h, where h is the maximum height achieved by the projectile. Ultimately we get an expression for h as equal to u square sin square theta by 2g. So another very important formula which will help us a lot in solving numerical problems. Now the time taken by the projectile in traveling, completing its trajectory and reaching the ground. The time taken is the time of flight. Let's try and find that out. Now look at this, the particle started from the point O. So the coordinates, if we try to write down the coordinates of this point, it is 0, 0. Now by the time the particle covers the trajectory and reaches point B, its coordinates change to 0, sorry, this distance is x, and or you can better call it r, the range of the projectile, and this, there is no displacement, so the y coordinate is 0. Now when we try to find out the time of flight, we use the expression s equal ut plus half at square. Again the vertical motion is involved here. So this displacement in going from O to B, what is the displacement? There is no displacement, no y coordinate, a 0 y coordinate, which gives us s as equal to 0. What is the component of u in the y direction? It is u sine theta. The time is the time of flight, we take it as capital T, and then this we have it as half a y, that is g, and this is t square, capital T square. Sign negative. So what are we left with? We have t, the time of flight, as twice u sine theta by g. So this is another important expression for the time of flight. Now you can see that by the time the particle is moving from O to B, it has covered a certain horizontal distance which was x. Now this distance that the particle covers in moving from one point to another, in completing its trajectory and hitting the ground, this is nothing but the range of the projectile. So we can write down expressions for range. So this was how we calculated the path of the projectile. Then comes the time of flight and the maximum height achieved. And now we come to the range of the projectile. Now how do we calculate the range of the projectile? Now range is basically nothing but ux times t. This is the horizontal component of the initial velocity times the time. So we can simply replace the values. Ux is u cos theta, t is 2u sin theta by g, and we get an expression for r as u square sin 2 theta by g. Now remember, what was the formula for sin 2 theta? Sin 2 theta is nothing but 2 sin theta cos theta. So that formula has been used here to write an expression for range. Now what is the condition for maximum range attained or maximum range of the projectile? Now as we can see from here, the range of a projectile is written as u square sin 2 theta by g. Now under what conditions can range be maximum? Range is maximum if sin 2 theta is maximum, and we know the maximum value of sin theta is 1. So sin 2 theta equals sin 90, or theta is equal to 45 degree. So this is another important concept that you need to keep in mind. Whenever a projectile is projected at an angle of 45 degree with the horizontal, its range is maximum. And what is the maximum value of range? You can simply put this in this equation. If theta is 45, then we have sin 90 as equal 1, and we get r max or maximum range as equal to u square by g. Now time for helpers. R by h is equal to 4 by tan theta. We can easily solve this by putting the values of r and h in this formula. Let us try and find this out. So it is r by h Now what is the expression for r? We have u square sin 2 theta upon g, and height, maximum height achieved is u square sin square theta by 2g. U square sin square theta upon 2g. So some terms get cancelled and we are left with So this is nothing but sin 2 theta is 2 sin theta cos theta. So we have this as tan theta in the denominator. We get 4 by tan theta. So this is indeed a very important formula. which you need to use in numerical problems. R by h is equal to 4 by tan theta. Now have a look at this. R by h is equal 4 by tan theta. Now what if a projectile is fired such that its range is maximum? When a projectile is fired in such a manner that its range becomes maximum, that is the maximum value of range is u square by g, then the maximum height achieved by the projectile in this case will be equal to r max upon 4. So this is very clear from this particular example. You can see that if range is maximum, which means that theta is 45 degree, so tan 45 will be 1 and we have h equal r by 4. Now from the formula for range, we can see that range of the projectile could be the same for two possible angles of projection. If you take a note at this drawing, you can see that r equal u square sine 2 theta by g. Now sine of any angle can be written as sine 180 minus that angle. That is sine theta is equal to sine of 180 minus theta. So sine 2 theta we can write it as sine of 180 minus 2 theta. Taking 2 common, we can see that we can write the expression as r equal u square sine 2 theta upon g, which is equal to u square sine of 2 times 90 minus theta upon g. So there are two angles of projection at which the range of the projectile could be maximum. One angle is theta and the other angle is 90 minus theta. So these helpers are to be borne in mind so that they prove to be of great help during numerical problem solution. Now let us look at some associated numericals. A boy wants to send a letter wrapped over a stone to his friend living across the street 40 meter wide. The boy's window is 10 meters below that of his friend's window. Find the magnitude and direction of the velocity of the stone. A very interesting problem. Let us look at this. Let us try to picturize this. We have a boy who wants to send a letter to one of his friends living across the street. So this is the street that we have and the distance is 40 meter. This is I believe it's a girl. So she's sitting here in her window and waiting for the letter as if, and the boy, he is at a certain height from the ground. His height is 10 meters below his friend's window. So this is 10 meter. Okay. So you see this, the width of the stone, and he sends the stone here. So the stone will come somewhere here, it will cover some more distance and finally it will come this way and fall somewhere here. It will come down. Okay. So this is the case. Now have a look at this. What are in hand? We have the distance of the boy's window and the distance of the girl's window. Say this is 40 meter. So what is the distance that the stone actually covers, which is the range of the stone or the range of the projectile here? The range is actually 40 into 2 times of this distance. So we first, what we get is the range of the projectile. The range r is equal to 40 into 2. This will help us in solving the question very easily. So we have a range of 80 meter. What else do we have in hand? Nothing as such. So we'll proceed with this. Okay. We have the height also, the distance of the boy's window and the girl's window. So this is 10 meter. So let me write an expression for range over here. Range is u square sine 2 theta by g, which is given as 80. This is an expression for range, and then we write down an expression for the maximum height achieved by the stone or the letter. So maximum height achieved is u square sine square theta by 2g. This maximum height achieved is 10 meters. We have two relations in hand. what we need to find out is the direction of velocity, that is theta, and we need to find out the magnitude of the velocity, that is u. So how do we get that? First, let us solve these two equations and get the value of theta, and then putting the value of theta in any one of the equations will give us the value of u. So let us mark these equations and 1 and 2, and then use the formula, the helper, r by h equal 4 by tan theta. No need to go for other formulas, we will directly use our helper over here. So we have tan theta is equal to 4h upon r. So it is 4 into 10 by 80. So it is half, or we can say tan theta is 0.5 or theta is equal to around 26.56 degree. Now substitute this value of theta in any of the above equations to get the value of u. We can see here that suppose we are using the first equation, u square sine 2 times of 26.56 degree by g, that is 9.8, is equal to 80. So just substitute the values and we are left with t or u equal 31.31 meter per second. So this is the velocity with which the boy has to send the letter to his friend. Now, let us now discuss the case of vertically launched projectiles. We have talked about what happens when a projectile has been launched at a certain angle with the horizontal, or we have talked about horizontal projectiles. Now, what if a projectile has been launched vertically? Imagine a stone thrown vertically up. What happens? You can hold a catch if you are good at that. Anyways, let us try to see that how we can derive expressions for the parameters from there. Now, vertically launched projectile means that the angle that the projectile is making with the horizontal is 90 degree. So, we have expressions for maximum height and time, and in these expressions we will simply substitute theta by 90 degree. So, we have h equal u square sin square theta by 2g. So, if theta is 90 degree, we have h equal u square by 2g. And time of flight, t was equal to twice u sin theta by g. So, we have u equal t equals twice u by g, since theta is 90 degree and sin 90 is equal to 1. And the range, take a note at the range. Range r is equal to u square sin 2 theta by g. Now substitute the value of theta. This is 90. So sine of 2 times 90, that is sine 180, which is 0. So take a note, range is 0 in case of vertically launched projectiles. So what does this actually mean? That when you are throwing a projectile, think of a stone vertically upwards, if you have maintained the angle, then the projectile will fall back into the hands of the thrower. Mind it, you have to go with the assumptions of projectile motion. That is, we had assumed that friction and acceleration due to gravity are not changing while we are describing projectile motion. If this was the case, then friction would have affected the motion and the projectile would not have fallen back into the hands of the thrower. So this is how you have to remember the concepts of physics and how they go. Now, let us discuss the case of projectiles which have been fired at some angle with the vertical. So this case is also quite easy. We just have to be concerned with the angle and the diagram. So we have a projectile here. The projectile is following a parabolic path. Say this is the path followed by the projectile. It has been fired with some initial velocity, but it is now making an angle theta not with the horizontal but with the vertical. So no worries, only that the components will change their places. The component of u, if this is theta, the component of u in the vertical direction, the vertical component will be, this component is u cos theta now, and this particular component is u sin theta now. So a projectile that has been projected at some angle with the vertical is the same as or is equivalent to a projectile that has been fired at an angle 90 minus theta with the horizontal. So look at this, this entire angle was 90 degree. So if this is theta, the remaining angle becomes equal to 90 minus theta. So that's simple the case. So we already have the expressions for maximum height, time of flight and range. We'll simply substitute theta by 90 minus theta in those equations. So we get maximum height as equal to u square sine square theta. It was theta, in place of theta we'll write down 90 minus theta. So this gives us a change in the trigonometric function. We have h equal u square cos square theta by g. Similarly, for the time of flight we have other expressions. Let's have a look at those. You can see t as equal to twice u sin 90 minus theta, which is again cos theta. So t equal twice u cos theta by g, and the range takes this particular form. You can see that in spite of substituting theta by 90 minus theta, there is no change in the range of the projectile. Range stands at u square sin 2 theta by g. Now some associated problems. Now this is one of my favorite problems. Just have a look at it. A boy throws a ball vertically upwards into air. When this ball reaches the highest point, he throws another ball up. How high do the balls rise if he throws twice in each second? So try to visualize this. By the time the first ball has reached the maximum height, the second ball is already thrown. Now during that time, what is happening to the first ball? It is coming down. Now recall, the time of ascent and the time of descent, which gives us the total time of flight, are equal. The time in which a projectile starts from its initial position and reaches the highest point, that is the time of ascent, and the time in which the projectile has come down from the maximum position to the ground, that is the time of descent, and these two parts of these two times, that is the time of ascent and the time of descent, they are equal to each other. So this concept will be applied here. By the time the first ball rises up to the highest point, the second ball is already thrown, and during that time the first ball already reaches the ground. So that is the total time taken by the first ball to start, reach the highest point, come to the ground. So that total time taken is 1 second, because he is throwing twice in each second. That means in 1 second it is completing the whole trajectory. That means what will happen for what is the time of descent or time of ascent? It is half of 1 second. That is 0.5 seconds. So this is the concept that we need to apply in this question. Otherwise the question is very simple. The ball has been thrown vertically upwards. Now when you are talking of upward motion, remember it is against gravity. So we have, let us try to solve this question on our own. So this is our problem. Let us consider this as ground. The ball is thrown up with a certain velocity. It is not at rest. We are not sure of the velocity. We do not know with what velocity the ball is thrown up. But only thing we know is that it reaches the highest point and then comes down again. By the time another ball is thrown. So this time, the time of ascent, and this is the time of descent. Now we shall not consider the time of ascent. Why? Because we are not aware of the initial velocity of the ball. It could have carried some velocity. So here, since u is unknown, we will not proceed with the upward motion. What we will consider in this particular problem is the downward motion of the ball. Now consider this, the highest point we know, as a ball or any object is rising up, it is trying to move against the pull of gravity. So by the time it reaches the highest point, the velocity here is 0. So let us consider the first ball and we shall consider the downward motion of the first ball. So the downward motion of first ball. We shall concentrate on this. For the downward motion of first ball, what all things do we know? We know the initial velocity of the ball. What is it? 0. Yes, because the ball started from the highest point. This was the downward motion. So the initial velocity is 0 here. And what is the time taken to come down and hit the ground? The total time was 1 second. So the time of downward motion, the time is half of 1 second. You can say that half second or 0.5 seconds. Now we are asked to find out how high do the balls rise, to what height they have risen. That is, we have to find out the distance. We shall use this formula. We shall replace s by h as if we are talking of height, and the formula is ut plus half at square. It will become better if we use g in times of a. So this is h equal, which we need to find out. Initial velocity is 0, so 0 into t plus half g is 9.8 and t square, t is 0.5. So 0.5 square, half whole square. Now if we work this out, we get h as equal to 1.225 meters. So an interesting problem. Now let us look at this. This is a problem involving a projectile which has been fired at some angle with the horizontal. Now a stone is projected at an angle theta from the ground with a velocity 39.2 meter per second. Find time of flight, horizontal range of the projectile or the stone in this case, and the maximum height reached by the stone. So simple formulas, we just need to put down the values and solve it. Let us do it on our own. So first, let us jot down whatever we have in hand. We have the velocity, the initial velocity in fact, u, which is equal to 39.2 meter per second. We have the angle of projection, theta, which is equal to 30 degree. Now the time of flight, t equal twice u sin theta by g. So put the values, 2 into u, that is 39.2 into sin 30, which is half, by g, 9.8. So this is 4.9, this is again 2. Ultimately we get t as equal to 4 seconds. Now the horizontal range r equal u square sin 2 theta by g. Put the values, u square, so 39.2 whole square, sin 2 theta, 2 into 30, so sin 60 degree, which is root 3 by 2, and g 9.8. So this will give us a range of 135.79 meters. Now the maximum height achieved by the projectile or the stone, u square sin square theta by 2g. So this is 39.2 whole square of it, sin square theta, that is theta is 30 degree, so half square, and this is 2 times g, that is 9.8. So we will get a maximum height as 19.6 meters. So an easy problem, the only thing that will affect are the calculations. Now this is another very important concept on projectiles. These concepts are to be very clear so that you can very easily crack the numerical problems associated, and also these concepts are very important for multiple choice questions. Now have a look at this drawing. So variation of the velocity components during the flight of the projectile. We consider a projectile . This is the path followed by a projectile, say. This is the maximum height. This is, say, A. Now, the projectile, suppose we have the projectile which is fired with a initial velocity u at an angle theta with the horizontal. We are sure, we know the horizontal components of the initial velocity, they are u cos theta and u sin theta. Now at any point on the trajectory, suppose we choose this particular point. At this point, this is the direction of motion of the particle. This is the horizontal component of the velocity. This is Vx, which is equal to ux. It is not changing. And what is happening to Vy? This Vy decreases. And by the time the particle reaches the highest point A, Vx is the same. The x component is the same, but the y component, Vy, this is equal to 0. And then further, suppose we consider any point here. This is the direction. Vy now increases. So you can see how the vertical component is changing with time. By the time the particle is advancing towards the maximum height or the maximum point, Vy goes on decreasing. At the highest point, Vy is equal to 0, and then Vy again increases. But throughout the whole trajectory, the horizontal component of the velocity remains the same. So this is to be noted. This is how the velocity components vary during the flight of a projectile. Now these two motions, that is the horizontal motion and the vertical motion, they are not dependent on each other. They are independent. The projectile will cover a certain horizontal motion, it will cover a certain horizontal distance. At the same time, it will also cover a certain vertical distance. So this horizontal and vertical motions, these are independent as well as simultaneous. So look at the helpers. At the highest point, the horizontal component of velocity is u cos theta. The vertical component at the highest point is 0. And the linear momentum of the projectile, which has been fired at an angle theta with horizontal, is mvx, mass times the velocity. It is mu cos theta, and the kinetic energy, if we are asked to write it down, it is half mvx square. You can substitute the value of vx and we get it as half m u square cos square theta. So this is how the velocity components vary during the flight of the projectile. Now we are already through with projectile motion. We have discussed what is projectile, the different ways in which projectiles may be launched, the different varieties and the different parameters associated with projectiles and everything. And we have also discussed some important numerical problems that are associated with projectiles. Thank you.